Plenum-rated cables have a special fire-resistant jacket that is designed to minimize smoke and toxic gas emissions in the event of a fire. This type of cable is required in certain areas where large amounts of airflow are present, such as in the plenum space of a building, which is the area between the ceiling and the roof. In many jurisdictions, the use of plenum-rated cabling is mandated by building codes for fire safety reasons. The National Electrical Code (NEC) and the International Building Code (IC) both require the use of plenum-rated cables in air handling spaces, such as plenums and attics. Sound system cabling typically includes audio, video, and control cables. These cables may be run through the attic space, which can be considered an air handling space in many churches. If non-plenum-rated cabling is used in a plenum space, it could violate building codes and pose a fire safety hazard. In the event of a fire, the non-plenum-rated cables could emit excessive smoke and toxic gases, which could hinder evacuation and firefighting efforts. Based on the fire regulations and codes, and considering the potential risks, it is strongly recommended to use plenum-rated cabling for sound system applications that are installed in attic spaces of churches. This will ensure compliance with building codes, protect the safety of occupants, and minimize potential fire hazards. In the context of electrical wiring, understanding the different types of cables and their applications is crucial for ensuring safety and compliance with building codes. Plenum-rated cables and non-plenum-rated cables serve distinct purposes and are designed for specific environments. The primary difference between plenum and non-plenum cables lies in their fire resistance and the materials used in their construction. Plenum cables are specifically designed for use in plenum spaces, which are areas in buildings used for air circulation, such as the space above a suspended ceiling or under a raised floor. These cables have a special insulation made from materials that produce minimal smoke and toxic fumes when burned. The purpose of this design is to prevent the spread of harmful smoke and gases through the ventilation system in the event of a fire, thereby protecting occupants and facilitating safer evacuation. Non-plenum cables, on the other hand, are not designed to meet the stringent fire safety standards required for plenum spaces. These cables typically have a polyvinyl chloride (PVC) jacket, which releases significant amounts of smoke and toxic fumes when burned. As a result, non-plenum cables are not suitable for use in plenum spaces and are generally used in other areas where fire safety requirements are less stringent. The National Electrical Code (NEC) provides detailed guidelines on the use of plenum and non-plenum cables. NEC Article 800, 113 and 800. 133 specifically addresses the requirements for communication cables, including those used in sound systems, and mandates the use of plenum-rated cables in plenum spaces. The code emphasizes the importance of using listed plenum cables that meet the standards set by organizations such as Underwriters Laboratories, AL. These standards ensure that the cables have been tested and certified to meet the required fire resistance and low smoke characteristics. The consequences of using non-plenum cables in plenum spaces can be severe. In the event of a fire, the excessive smoke and toxic fumes released by non-plenum cables can quickly spread through the ventilation system, creating a life-threatening hazard for building occupants. This can hinder evacuation efforts and make it more difficult for firefighters to control the blaze. Additionally, using non-plenum cables in plenum spaces can result in code violations and potential legal liabilities for building owners and contractors. To ensure compliance with building codes and protect the safety of occupants, it is essential to use plenum-rated cables in plenum spaces. These cables are readily available from electrical suppliers and are typically marked with the designation CMP, which indicates that they meet the plenum cable requirements. When selecting plenum cables, it is important to verify that they are listed by a recognized testing laboratory and that they meet the specific requirements of the application. In addition to plenum and non-plenum cables, other types of cables are available for specific applications. Riser cables, for example, are designed for use in vertical shafts or risers that run between floors in a building. These cables have a fire-resistant jacket that is designed to prevent the spread of fire from one floor to another. However, riser cables are not suitable for use in plenum spaces because they do not meet the stringent smoke and fume requirements. Another type of cable is the general purpose cable, which is typically used in residential and light commercial applications. These cables are not designed for use in plenum or riser spaces and should only be used in areas where fire safety requirements are less stringent. When installing electrical wiring, it is important to follow all applicable codes and regulations. The NEC provides detailed guidelines on the proper installation of cables, including requirements for support, spacing, and protection from physical damage. It is also important to use the correct type of connectors and fittings for the cables being installed. Proper installation practices can help to ensure the safety and reliability of the electrical system. In summary, understanding the differences between plenum and non-plenum cables is essential for ensuring fire safety and compliance with building codes. Plenum cables are specifically designed for use in plenum spaces and have a special insulation that produces minimal smoke and toxic fumes when burned. Non-plenum cables are not suitable for use in plenum spaces and should only be used in areas where fire safety requirements are less stringent. By following the guidelines provided in the NEC and using the correct type of cables for the application, it is possible to create a safe and reliable electrical system. Furthermore, when dealing with sound system installations in environments like churches, the selection of appropriate cabling is not merely a matter of regulatory compliance but also one of ensuring the long-term reliability and performance of the system. The attic space in a church, while seemingly benign, presents a unique set of challenges that can impact the integrity of the sound system if not addressed properly. Temperature variations, humidity levels, and potential exposure to dust and other contaminants can all contribute to the degradation of cable performance over time. Plenum-rated cables, in addition to their fire safety characteristics, often exhibit superior resistance to these environmental factors compared to non-plenum-rated cables. The materials used in their construction are typically more robust and less susceptible to deterioration from exposure to heat, moisture, and chemicals. This enhanced durability translates to a longer lifespan for the cabling and a reduced risk of signal degradation or failure. In the context of a sound system, this is particularly important as even minor disruptions in audio or video transmission can detract from the overall experience and impact the effectiveness of the service or event. Consider the scenario of a church service where the sound system is critical for delivering the message and engaging the congregation. If the cabling used to connect the microphones, speakers, and other audio equipment is not properly protected from environmental factors, it may be prone to intermittent failures or signal distortion. This can result in dropped audio, static interference, or other audible anomalies that distract from the service and diminish the impact of the message. By investing in plenum-rated cables, the church can minimize the risk of these issues and ensure a consistent, high-quality audio experience for the congregation. Moreover, the installation of cabling in an attic space often involves navigating around various obstacles such as pipes, ducts, and structural supports. This can put additional strain on the cables and increase the likelihood of damage or wear. Plenum-rated cables are typically designed with a more robust construction that can withstand the rigors of installation and provide greater protection against physical damage. This is particularly important in areas where the cables may be subject to abrasion, bending, or compression. In addition to the physical characteristics of the cables, it is also important to consider the connectors and termination methods used in the sound system installation. High-quality connectors and proper termination techniques are essential for ensuring a reliable and secure connection between the cables and the audio equipment. When selecting connectors, it is important to choose those that are compatible with the type of cable being used and that are designed for the specific application. For example, shielded connectors may be necessary to minimize electromagnetic interference (EMI) in areas where there are high levels of electrical noise. Proper termination techniques involve carefully stripping the cable insulation, crimping or soldering the connectors to the conductors, and ensuring that the connections are secure and free from corrosion. Poorly terminated connections can result in signal loss, distortion, or even complete failure of the audio system. Therefore, it is important to invest in the necessary tools and training to ensure that the connections are made correctly. Furthermore, the the layout and routing of the cables in the attic space can also impact the performance and reliability of the sound system. It is important to avoid running cables near sources of electrical noise, such as power lines or fluorescent lighted fixtures. These sources can generate electromagnetic interference that can degrade the audio signal and introduce unwanted noise into the system. Cables should also be routed in a way that minimizes the risk of physical damage or strain. This may involve using cable trays, conduits, or other support structures to protect the cables and keep them organized. In addition to these practical considerations, it is also important to factor in the long-term maintenance and upkeep of the sound system. Regular inspections of the cabling and connections can help to identify potential problems before they escalate into major issues. This may involve checking for loose connections, damaged cables, or signs of corrosion. By addressing these issues promptly, it is possible to prevent costly repairs and ensure the continued reliability of the sound system. In conclusion, the selection of appropriate cabling for a sound system installation in the church attic involves a multifaceted assessment of fire safety requirements, environmental factors, and long-term performance considerations. While Plenum-rated cables may represent a higher initial investment, their superior fire resistance, durability, and resistance to environmental factors make them a worthwhile choice for ensuring the safety, reliability, and longevity of the sound system. By following best practices for installation, termination, and maintenance, it is possible to create a sound system that delivers exceptional audio quality and enhances the worship experience for the congregation. Now let's delve deeper into specific aspects of the National Electrical Code, NEC, and its implications for sound system installations, particularly in the context of plenum spaces and church environments. The NEC is a comprehensive set of standards and guidelines that govern the safe installation of electrical wiring and equipment in buildings. It is updated every 3 years to reflect the latest advancements in technology and to address emerging safety concerns. While the NEC is not a law itself, it is widely adopted by state and local jurisdictions as the basis for their electrical codes. Therefore, compliance with the NEC is often mandatory for ensuring the safety of building occupants and for obtaining permits and approvals for electrical installations. Article 725 of the NEC pertains to Class 1, Class 2, and Class 3 remote control, signaling, and power-limited circuits. These circuits are commonly used in sound systems for applications such as controlling amplifiers, mixing consoles, and other audio equipment. The NEC specifies the requirements for wiring methods, overcurrent protection, and grounding for these circuits to minimize the risk of electrical shock and fire hazards. Section 725.136 of the NEC addresses the installation of Class 2 and Class 3 cables in plenum spaces. It mandates that these cables must be listed as plenum cables or be installed in a metal raceway. This requirement is intended to prevent the spread of fire and toxic fumes through the plenum space in the event of a fire. The NEC also provides guidelines on the ampacity of conductors used in sound systems. Ampacity refers to the maximum amount of current that a conductor can carry safely without exceeding its temperature rating. The NEC specifies ampacity tables for different types of conductors based on their size, insulation material, and installation conditions. It is important to select conductors with adequate ampacity to prevent overheating and potential fire hazards. In addition to the NEC, other standards and guidelines may also apply to sound system installations in churches. For example, the Audio Engineering Society (EASE) publishes technical standards and recommended practices for audio equipment and systems. These standards cover a wide range of topics, including grounding, shielding, and signal levels. Adhering to AES standards can help to ensure optimal performance and minimize noise and interference in the sound system. Furthermore, local building codes may impose additional requirements for sound system installations. These requirements may vary depending on the jurisdiction and the specific characteristics of the building. It is important to consult with local building officials to determine the applicable codes and regulations before commencing any installation work. When planning a sound system installation in a church, it is essential to consider the specific needs and requirements of the congregation. The size of the sanctuary, the acoustics of the space, and the types of services and events that will be held all play a role in determining the appropriate sound system design. A qualified audio engineer can help to assess these factors and develop a system that meets the needs of the church. The selection of speakers is a critical aspect of sound system design. Different types of speakers are available for different applications, including loudspeakers, subwoofers, and line arrays. Loudspeakers are typically used to provide general sound reinforcement, while subwoofers are used to reproduce low-frequency sounds. Line arrays are vertical arrays of speakers that are designed to provide uniform coverage over a large area. The placement of speakers is also important for achieving optimal sound quality. Speakers should be positioned to minimize reflections and to provide even coverage throughout the sanctuary. Acoustic treatment may also be necessary to improve the acoustics of the space and reduce unwanted reverberation. The choice of microphones is another important consideration for sound system design. Different types of microphones are available for different applications, including dynamic microphones, condenser microphones, and wireless microphones. Dynamic microphones are rugged and durable, making them suitable for live performances. Condenser microphones are more sensitive and provide better sound quality, making them ideal for recording and studio applications. Wireless microphones offer freedom of movement and are often used by pastors and speakers. The selection of a mixing console is also a key aspect of sound system design. A mixing console is used to control the levels and tone characteristics of the various audio signals in the system. Mixing consoles are available in a variety of sizes and configurations, ranging from small analog mixers to large digital consoles. Digital mixing consoles offer advanced features such as signal processing, automation, and recall. In addition to the core audio equipment, other components may also be necessary for sound system installation, including amplifiers, signal processors, and cabling. Amplifiers are used to boost the audio signals to the appropriate levels for the speakers. Signal processors are used to shape and manipulate the audio signals to improve sound quality and reduce noise. Cabling is used to connect the various components of the system together. In conclusion, sound system installations in churches require careful planning and attention to detail to ensure safety, performance, and compliance with applicable codes and standards. By working with qualified professionals and selecting appropriate equipment, it is possible to create a sound system that enhances the worship experience for the congregation and serves the needs of the church for many years to come. Also, let's explore some advanced concepts related to plenum cabling and its role in ensuring safety and performance in complex sound system installations. In addition to the basic requirements for fire resistance and low smoke emissions, plenum cables offer several other advantages that make them a preferred choice for critical applications. One of these advantages is their superior flexibility and durability. Plenum cables are typically constructed with high-quality materials that can withstand repeated bending and flexing without compromising their electrical performance. This is particularly important in installations where cables are routed through tight spaces or are subject to frequent movement. Another advantage of plenum cables is their resistance to chemical degradation. Plenum cables are often exposed to a variety of chemicals and contaminants in the environment, such as cleaning agents, solvents, and lubricants. The materials used in plenum cables are designed to resist these chemicals and prevent them from degrading the insulation or conductors. This helps to ensure the long-term reliability of the cables and prevent premature failure. In addition to these practical benefits, plenum cables also offer advantages in terms of signal integrity. The high-quality construction and materials used in plenum cables can help to minimize signal loss and distortion, resulting in improved audio and video performance. This is particularly important in applications where high-bandwidth signals are transmitted over long distances. When selecting plenum cables for sound system installation, it is important to consider the specific requirements of the application. Factors to consider include the type of signals being transmitted, the distance of the cable runs, the environmental conditions, and the applicable codes and standards. It is also important to choose cables that are properly shielded to minimize electromagnetic interference. Shielded cables have a layer of conductive material that surrounds the conductors and helps to block out external noise and interference. This can be particularly important in environments where there are high levels of electrical noise, such as near power lines or electronic equipment. In addition to the cables themselves, the connectors and termination methods used in a sound system installation can also have a significant impact on performance and reliability. It is important to use high-quality connectors that are designed for the type of cable being used. Connectors should be properly crimped or soldered to the conductors to ensure a secure and reliable connection. It is also important to use appropriate strain relief to prevent the cables from being pulled or stressed at the connection points. Proper grounding is another critical aspect of sound system installation. Grounding helps to prevent electrical noise and interference and also provides a path for fault current in the event of an electrical problem. All components of the sound system should be properly grounded to a common ground point. The grounding system should be designed in accordance with applicable codes and standards. Regular maintenance and inspection are essential for ensuring the long-term reliability of a sound system. Cables and connectors should be inspected periodically for signs of damage or wear. Any damaged or worn component should be replaced promptly. The grounding system should also be inspected to ensure that it is functioning properly. In addition to these technical considerations, it is also important to address any aesthetic concerns related to the sound system installation. Cables should be neatly routed and concealed whenever possible to minimize visual clutter. Cable ties, conduits, and other accessories can be used to organize and protect the cables. The speakers and other components of the system should be positioned in a way that is both functional and visually appealing. In conclusion, Plenum cabling plays a vital role in ensuring the safety and performance of complex sound system installations. By selecting high-quality cables, using proper termination methods, and following best practices for grounding and maintenance, it is possible to create a sound system that delivers exceptional audio and video quality and provides years of reliable service. Moreover, let's discuss some of the challenges and best practices associated with installing Plenum-rated cabling in church environments, focusing on aspects specific to these spaces. Churches often present unique architectural and structural characteristics that can complicate cable installation. High ceilings, intricate woodwork, and historical preservation considerations can all pose challenges for routing cables and concealing them effectively. Furthermore, the presence of sensitive equipment such as pipe organs and antique lighting fixtures requires careful planning and execution to avoid interference or damage. When installing Plenum-rated cabling in a church, it is essential to work closely with the church's building committee or facilities manager to understand the specific requirements and constraints of the space. This collaboration should begin early in the planning process to ensure that the cable installation is integrated seamlessly with the existing infrastructure and that any potential conflicts are addressed proactively. One of the key challenges in church environments is concealing cables effectively without disrupting the aesthetic integrity of the space. Surface-mounted cable trays or conduits can be unsightly and detract from the beauty of the architecture. Therefore, it is often necessary to explore alternative methods of cable concealment, such as running cables through existing wall cavities, ceiling spaces, or underfloor channels. However, these methods can be more labor-intensive and may require specialized tools and techniques. Another challenge in church environments is minimizing the impact of the cable installation on the acoustics of the space. Cables can vibrate and resonate, creating unwanted noise and interference. To mitigate this issue, it is important to secure the cables properly and to use damping materials to reduce vibrations. Cables should also be routed away from reflective surfaces to minimize reflections and echoes. In addition to these physical challenges, there are also several safety considerations that must be addressed when installing Plenum-rated cabling in a church. Churches often have a large number of occupants, particularly during services and events. Therefore, it is essential to ensure that the cable installation is safe and does not pose a hazard to occupants. Cables should be properly supported to prevent them from sagging or falling. Cables should also be protected from physical damage to prevent electrical shock or fire hazards. Furthermore, it is important to use appropriate personal protective equipment, PPE, such as gloves and safety glasses, when handling cables and working in confined spaces. In addition to these safety considerations, there are also several ethical considerations that must be taken into account when installing Plenum-rated cabling in a church. Churches are often places of worship and spiritual reflection. Therefore, it is important to treat the space with respect and to minimize any disruption to the services or events that are held there. Work should be scheduled to avoid peak hours and to minimize noise and disturbance. Workers should also be mindful of their language and behavior while on the premises. In conclusion, installing Plenum-rated cabling in a church environment requires careful planning, attention to detail, and a strong commitment to safety, aesthetics, and ethical conduct. By working closely with the church's building committee or facilities manager, and by following best practices for cable concealment, acoustic mitigation, and safety, it is possible to create a cable installation that is both functional and visually appealing, and it enhances the worship experience for the congregation. Furthermore, it is crucial to keep abreast of the latest technological advancements and industry best practices related to cabling and sound system installations. Continuous learning and professional development can help to ensure that sound system installations are performed safely, effectively, and in compliance with applicable codes and standards.